Hello, welcome back to the video series for Geography 300, Geographical Data Analysis at West Virginia University. As we've seen starting with last week, we're starting to bring in space into our statistics. Last week we were indirectly using spatial ideas to generate predictions, and we tested those predictions against what actually was happening. Now we are really making the relationships across space more explicit and testing those more directly. This first is through something called spatial autocorrelation. This first video breaks down the idea of spatial autocorrelation. So first, look at basically the term and take it apart to see what it is actually trying to measure or understand. If we just break apart the term, starting from the end, correlation. Correlation is two things related to each other, co-relate. So, if we think about that, it's about this kind of relationship. We will see in a few weeks, looking at regression, correlations in general. This has a particular form of correlation, autocorrelation. Auto being with itself. So you might be wondering, how can something be related to itself? The idea started out for autocorrelation with time series. Yesterday's temperature is autocorrelated with today's temperature. So temperature has this function of autocorrelation. It doesn't vary a huge amount from one day to another, one time period to another. The same can be applied to many, many time series. Temperature just happens to be a good example. The space comes in, spatial, instead of looking at the relationship between a variable or an attribute and itself at a different point in time. This is looking at the relationship between the variable and itself at some other location across space. So the idea then becomes is there a relationship between a place and its neighbors? We can have, the way it's written there is either yes or no. Really, we can have three different possibilities. So we can say, if it's not related, if those are independent of each other, we'll see more on that in one of the later videos on this topic. If they are independent of each other, there's no relationship at all, then there's no autocorrelation. If, however, they are related, so now we can say if they are related, a place could either be similar to its neighbors or not similar or very dissimilar from its neighbors. And that is a different setup than no autocorrelation at all. If they are similar to the neighbors, and that's the most common of the two yes answers, in geography, best to say things like, for income, the median income for Mon County can be related to the median income for Preston County. They can be similar, and in many cases where there could be similar or the same employers paying the same amounts, it makes sense that there would be a fair amount of relationship between those two, a fair amount of similarity. For temperature, even stronger, that the average high temperature for today in Mon County would be very similar to the average high for the same day in Marion County. So if they are similar, we would say that is a positive spatial autocorrelation. A place is similar to its neighbors. We can have, though, a setup where they're not similar, where they're dissimilar from each other. And that would be negative spatial autocorrelation. As a case in point, the negative autocorrelation, the typical example there is a chessboard. A white square is always next to a black square. As long as you do up, down, left, right, no diagonals, white and black always neighbor the other color. So a square is guaranteed to be dissimilar from its neighbors. That is a different setup than no autocorrelation. Because if I can tell you the value at a square, if I tell you this square is white, that means if it's a positive autocorrelation setup, you know the neighbors are probably going to be white. So I gave you information about the neighbors by telling you the value here. For a negative autocorrelation, I also told you information about the neighbors. If I said this one is white, then you know the neighbors are probably black. The neighbors are different because of the chessboard setup. A no autocorrelation situation would be if you had a plain white board and you got out a marker, and for each square you flipped a coin. If it came up heads, leave it white. If it came up tails, make it black. If I then tell you this square is white, because of the way those coin flips work, you have no idea whether the neighbors are white or black. You don't have that information. You cannot figure that out, and that's why that is a set of no autocorrelation. There's no information about the neighbors, and how that is different from both positive and negative spatial autocorrelation. And I'll point out the approach, it's not just black and white, literally. It actually is used for continuous variables. But the same general idea, places are similar to their neighbors if it is a positive spatial autocorrelation setup, dissimilar from their neighbors if it is negative, no relationship at all if there is no autocorrelation. The last item here for this introduction to spatial autocorrelation is the idea of just how fundamental it can be considered for geography. In other courses, you may or may not have heard about something called Tobler's first law of geography. That law, presented actually kind of tongue-in-cheek, was stated, everything is related to everything else. But near things are more related than distant things. That idea, near things are more related than distant things, that is a summary of spatial autocorrelation. The idea existed long before Tobler wrote that statement. The idea that near things are more related than distant things is the essence of spatial autocorrelation, and in particular positive spatial autocorrelation. So that is the idea. If you are similar to your neighbors or dissimilar from your neighbors, you have spatial autocorrelation, either positive or negative. If there is no relationship at all, there's no autocorrelation. The next video will take one of the ideas I just kind of glided over. A place is similar to its neighbors. How do we know who my neighbors are? That question is what we get to in the next video. So as always, if you have questions, feel free to send me an email. Feel free to speak up in the Zoom class. Thank you for watching. Have a good one.